Hello, welcome to PhysQuest. So this is the solution video for CSIR NET December 2019 Part C, question number 17. The question is, which of the following decay processes is allowed? So 4 decay processes are given and we need to choose the right one. So let's get started. So this question comes from the section particle physics and the concept involved here is conservation laws. So let us talk about the conservation law. So in any type of physical process or any interaction, classical conservation law has to be satisfied. Those are conservation of charge, conservation of energy or mass, then conservation of momentum, and that also includes both the linear momentum as well as the angular momentum. So these are the basic conservation law which has to be satisfied. Now apart from that, there are some other specific laws which are particle specific conservation laws. So those are, first of all, that's conservation of baryon number, then conservation of lepton number. Now leptons falls into 3 families, that is electron family, muon family and tyon family. So therefore apart from lepton number conservation, there are 3 lepton specific conservation laws, that is electron family number, muon family number and tau family number. So these are the besides lepton number conservation, these specific family number conservation also has to be satisfied. And then there is also the conservation of strangeness. So all these are the particle conservation laws. Now out of these, the strangeness conservation is specific to strong interaction only. So now all these conservation law has to be satisfied for any particle interaction to occur. But our main focus will be to check the conservation of charge, baryon number, lepton number and their specific lepton specific number conservation. So now let's go ahead with our options which are given. So these are the 4 decay process we are given. Now we will discuss them one by one. First let's talk about the muon giving electron and gamma. So in this case, if we talk about the charge conservation, muon has the charge -1, electron has -1 and gamma is 0. So charge conservation is satisfied. Then baryon number. So here none of them are baryons. So here it is for both of them the baryon number is 0, so it is satisfied. Now let's talk about the lepton number. Now lepton number, here muon and electron both are leptons. So for each of them it is +1. So here also for both the sides lepton number is satisfied, so we can say lepton number is conserved. Now as I said, we need to also check the lepton specific conservation, that is first of all that is L mu. So for here if we check the L mu, that is for muon conservation number, for muon for left hand side muon having lepton number +1, but for electron it is 0 and for gamma it is of course 0. So this is not satisfied here. Again if we check the electron specific conservation, here for muon this is 0, but for electron it is +1 and for gamma it is 0. Again this is not satisfied. So since the lepton specific conservation laws are not conserved here, so this process is not allowed. Now let's move ahead to next decay process, that is neutron giving proton and pion. So here if we check the charge, here for neutron it is 0, for proton it is +1, for pi it is -1, so charge conservation is satisfied. For baryon, neutron and proton both are baryon but pi is a meson, so this is +1 and here +1 +0, which is satisfied. Next let us check the lepton number. Now none of them are leptons, so for all of them it is 0, so it is satisfied. Now if we check the lepton specific number, here also these numbers are also satisfied. So here we can it seems that this decay process is satisfying all the major conservation law. But before confirm it as a allowed decay process, we must check the mass conservation or the energy conservation. So if when you do that, for neutron, this is the rest mass is 940 MeV per c square, and for proton it is 938, and for pion it is 140. This is in the units of mega electron volt per c square. So now in any particle decay, the parent nuclei must have higher mass than the product. But here in this case, neutron has a mass of 940, whereas the proton plus pion is giving a total mass of 1078, which is less than the product has higher mass than the parent nuclei. So here we can say that this is not following the conservation of mass or energy. So this process is also not allowed. So now let's move ahead to the next process, which is neutron giving pi plus and pi minus. So here if you check the charge, it is conserved. Then if we check the baryon number, here neutron is a baryon, so it has baryon number +1, but pions are not, so for them it is 0, so it is not satisfied. And lepton number, since none of them are leptons, so lepton number is satisfied, but since baryon number is not conserved, so this process is not allowed. Now let's move ahead to the last process, which is kaon giving mu plus and mu minus. So if we check the charge, here the conservation of charge is satisfied. Now baryon, none of them are baryon, so this is also satisfied. Now if we talk about leptons, kaon, for kaons lepton number is 0, but for muons are leptons, so for mu plus it is -1, and for mu minus it is +1, so this is also satisfied. And when we check the lepton specific law, L mu, this is also the same, that is, it is satisfied. And for the electron specific lepton number, for all of them it is 0, so it is also satisfied. So again, the major conservation law, it is satisfying. So now again we have to check the conservation of mass or energy. So when we do that, the conservation of if we check the conservation of mass for kaons, this is 498 MeV per c square, and for muons, this is, for each of them it is 106 MeV per c square. So here if we check here, kaon has mass higher than the total mass of the both the muons, muon and the anti-muon, which is 212. So this is satisfying the mass energy conservation. So now one thing you can say here is the strangeness is not conserved. Kaon is a strange particle, but muons are not, so strangeness conservation is not happening here. But I already said strangeness conservation is specific for strong interaction only, and in the question it is not mentioned that whether the given interaction is a strong interaction or not. So we can say that this decay process is satisfying all the conservation law, so this process is allowed. Now if we check all the option, you can see that option A is the reaction which is satisfying all the law. So correct answer for this question is option A.